Welcome to another class of the teleconnection patterns and S2S predictability course. Today, our invited speaker is Professor Paola Arias. She is a full professor at the School of Environmental Science at the Faculty of Engineering at the University of Antioquia in Colombia. She is co-chair of the GUX Hydroclimatology panel and a member of the Monsoons Working Group. Her research focuses on climate variability and change in North and South America, particularly atmospheric moisture transport and interhemispheric teleconnections in the region, including, of course, the American monsoons. Paola will talk about the climatology of the Americas for us today. Welcome to the course, Paola, and you can share your screen and you can introduce yourself if you want. If I forgot some specific detail, you are free. The space is yours.
Thanks a lot, Michelle. Hi, everyone. I am Paola Arias at Universidad de Antioquia in Medellin, Colombia. It's a pleasure to be here. As Michelle mentioned, I am part of the working group on the American monsoons of the CLIVAR panel on monsoons. And this is one of the activities that when Michelle started co-chairing this working group, like we wanted to have it. And it's like not only having scientists, talking about these topics, but more having like a broad idea also of the monsoons and the research that we are performing on the American monsoons in particular. And it means also like education, like having some training courses. And this is the idea of this seasonal to subseasonal predictability course that Michelle has been organizing for a while now. So the idea today is that I'm going to talk more about the climatology of the American monsoons. You had a first class with Michelle where you started like having some common background on the monsoons. So she already explained in general what is a monsoon, in what are like the main features of a monsoon. So I'm not going to refer to that specifically, but I'm going to talk about the American monsoons, how the American monsoons behave, like what is the annual cycle in terms of the wind circulation, but also precipitation, etc., both in North and South America. And we will discover that although they are monsoons, so they share some common features, they can be quite different depending on the region where they act. So sorry, my computer is quite slow now. I don't know why. I'm trying to put in presentation mode. Are you seeing the screen?
Not yet.
Okay, let me see if I'm doing. Let's see. It's because my computer is super slow and it's not allowing me to share. Sorry, let's see. Do you see it now?
No. Yes. Now okay. It's working.
Okay, perfect. So as I mentioned, the idea today is to discuss a little bit on the climatology of the American monsoons. What are the climatological behavior of these two monsoons in the Americas? So as Michelle already explained to you last week, a monsoon is a seasonal circulation that is characterized by changes in wind direction. One type of circulation during the summer months, another type of circulation during the winter months, and is basically driven among many other aspects, but the thermal contrast between the land and the ocean is very important to have this reversal in the wind circulation. So as Michelle already explained, there are monsoons in all the continents, both in the Northern Hemisphere and in the Southern Hemisphere. Here we can see in highlight in these shades represent some of the monsoons that have been already studied and that are recognized in the literature as monsoons. So you can see like the very well and very well studied monsoons in Asia, the South Asia monsoon and the East Asian monsoon. And you also have like the counterpart in the Southern Hemisphere, that is the Australian and maritime continent monsoon. We also have in Africa, so we have the West African monsoon, that is like the monsoon that receives most of the attention in terms of studies in Africa. But we also have a region that there is some debate in literature in terms of whether this is a monsoon or not, independently that there is a huge scientific community in South Africa that recognize this as a monsoon. So here I'm going to talk about this as another monsoon, which is the South African monsoon. And then we have the American monsoons, the North America and the South American monsoons. I put them in green because these are the two monsoons that we are going to focus on today, but also because it's quite new. I mean, when you start seeing the literature, like when was like widely recognized that South America in particular has a monsoon circulation, is from the early 90s, late 90s. So it is, let's say, 30 years the most. And when you compare, for instance, with the South Asian monsoon, also called as the Indian monsoon, I mean, this can be between the 1800s, the first literature, even the 1600s, like 4 or even 5, almost 5 centuries ago, the first studies about this circulation in South Asia. So it's quite young in terms of the recognition of the international community that there is a monsoonal circulation in South America. And as we are going to see, this pattern of a 180 degrees reversal in the wind direction is something that is not happening in the American monsoons, particularly the South American monsoons, but it doesn't mean that this is not a monsoon circulation. So that's why I'm going to refer to these monsoons, like having in mind that there are some differences among the monsoons. That is something super important. Like, let's say that each one of these monsoons is a particular animal and each one has his own or its own personality. So the South Asian monsoon is quite different from the West African monsoon or from the Australian and maritime continent monsoon. There are specificities of these monsoon circulations, geographic, land use, land cover, atmospheric patterns, etc., that makes that each of these monsoons are quite different. So that's why you don't have someone that is an expert in all the monsoons. We become experts more in one particular monsoon and sometimes in one particular feature of this specific monsoon. So it's something that, of course, we have a lot of scientists studying different particularities, different aspects of the monsoons. So today we are going to focus on this, the American monsoons. So when we go to this image, we are seeing like all the monsoon systems that I already showed you. You are seeing, I will start from the left from the right, sorry, to the left, starting with the Asian and Australian monsoon systems. So in all these figures, what you are seeing in the top is the Northern Hemisphere monsoons, and in the bottom, the Southern Hemisphere monsoons. This is a very, probably you know this image from the NOAA that is showing us in colors the outgoing long wave radiation. So this is somehow like an indication of convective activity. So when we have very deep clouds that have very high tops, those tops are very cold. And when they are cold, they emit less long wave radiation than when they are hot. So that's why you see in blue, which means lower values of OLR, associated with deep convection in the tropics. So somehow we could try to interpret these shaded blue and green areas as regions with a lot of precipitation. You are also seeing like some arrows here that are indicating low-level circulation. In red, they are showing us like the dominant low-level circulation. So here we can see like how is the wind blowing in that particular region in that particular time of the year. And here is not that clear, but you are seeing also some streamlines. Here, for instance, I'm going to follow this. These streamlines that are all these solid lines are showing us the upper troposphere circulation. So monsoons are very deep circulations. They are not only low-level circulation, they are also related with a rising motion in the atmosphere, but also you have another circulation, like a contracting circulation in the upper troposphere. So that's why we are seeing like the low level, the high level, but also like an indication of convective activity associated with the monsoon. So here we are seeing in the right, the Asian, Australian monsoon systems. Here we are seeing by July 22nd, that is generally climatologically the peak of the monsoon in Asia and in South Asia and East Asia. And here you are seeing like the circulation almost 6 months after. This is January 18, when is the peak of the Australian maritime continent monsoon. And here you are seeing in this inset map the topography. You are seeing here that this is Asia, the south of Asia, and here you're seeing Australia, for instance, and the maritime continent. So basically what we can see is a clear convective activity toward the northern hemisphere, particularly focused on Asia, both South Asia and East Asia during the summer months. We know that this is reasonable because then we have a continent mass that is warmer because it absorbs and heats more than the ocean. And then we have the circulation, low-level circulation, that is showing us that the wind is blowing from, in this case, Australia and the maritime continent toward East Asia. And in this case, we are seeing these winds that are initially trying to go to Africa, but then you can see the reversal in the direction, and it's associated with, because we have the sea level pressure gradient that we are having here, but also we have Coriolis changing the sign, so deflecting, changing the trajectory to the right. So that's why we are seeing this wind going into this direction, and it brings moisture toward the warm land, and then we can start having a rising motion that promotes precipitation over the region. So we are seeing this very consistent pattern. And then when we go to the upper troposphere, if here is not very clear the movement of the arrow, but I'm doing this with my mouse. There you are seeing that there is a circulation in this case that is clockwise, is in this direction, and that is associated with the divergent flow, because if you have convergence in the bottom, you have rising motion. Then in the upper troposphere, you will have divergence. And we know that in the northern hemisphere, we have divergence in a rotation that is clockwise. So here we are seeing the anticyclone, the upper tropospheric anticyclone that is associated with the South Asian monsoon, that is called the Tibetan High, because it's located over the Tibetan Plateau. And then when we go in the southern hemisphere summer, we can see like a very, not exactly opposite pattern, but we can see a clear reversal. For instance, we see that here over this region that is winter now, you don't have precipitation. But then you have that the precipitation region has migrated to the south. So you can see now the convective activity more focused on the maritime continent and northern Australia. You can see also that the winds here that were coming in this direction now, they are flowing through to Africa. This will be actually very important to feed the South African monsoon. That will be this circulation that we are seeing here. And here you can see very clearly the reversal of the wind. That now we are having winds that are entering to the maritime continent and Australia instead of entering into the Asian region. So yes, here you can see very clearly the reversal of the wind. That is like the initial definition of monsoon. Monsoon comes from an Arabian word that is associated with changes in direction. And the other thing that you can see here, again, I'm going to move like it is supposed to be. This movement here, you see that there is a movement in the upper troposphere that in this case is counterclockwise and is associated with the same phenomenon. You have the divergence in the upper troposphere, and because we are in the southern hemisphere, this circulation won't be clockwise, it will be counterclockwise because of the Coriolis effect. If we go to Africa, then we see something very similar. We see that the convective activity is much more reduced in these regions in comparison to particularly the Asian monsoons, but we can see very similar features. Again, like by the peak of the West African monsoon, we can see the wind blowing into the North African or West African continent consistently with the convective activity. So again, you have convergence in the low levels, rise in motion, and then you will have a divergence in the upper troposphere. And there we can see a little bit of that divergence. If I try to do this, this is what the wind is doing. So again, it's doing a circulation that is divergent and is clockwise, similar to here, because we are in the northern hemisphere. And then when we go to the southern hemisphere summer, in this case here, they are showing in January 28, that is the peak of the South African monsoon. Then we can see here a very clear reversal of the wind. Now, these are the trade winds that are trying to go to South America in this case. Then we see here the convective activity more focused, more centered in the south. And in this case, part of these winds, in this case, that are coming from the South Asia region are coming and feeding with moisture transport over this region in South Africa. So here in this region, you don't see specifically a wind, a reversal in the wind direction. And that is one of the reasons why like in the hegemonic science, very northern hemisphere and more than northern hemisphere, global north dominated, this is not necessarily treated as a monsoon in the same way that, for instance, the West African monsoon. And then we go to the Americas. We can see here again, northern hemisphere, in this case, is the peak of the North American monsoon that is mostly by mid-July. And then the peak of the South American monsoon that is like climatologically around mid-January. So you can see again the migration of the convective activity. You can have more in the northern hemisphere in the summer in the northern hemisphere, and you have, when we have the southern hemisphere summer, the migration toward the south. We can see also, like in low level, how is the circulation. So I'm going to talk about this more clearly in the following slides, but you can see here one part of the moisture transport that feeds the North American monsoon comes through the Californian Gulf, but then you also have an important part in the mid and upper levels that come from the Gulf, the Gulf of Mexico over this region. You can also see that the convective activity and precipitation is mostly in the equatorial region, not that much, at least when you compare with these values here over Asia or over South Africa, that the amounts of precipitation are much less, but it doesn't mean that that precipitation is not, doesn't play a key role for the vegetation and ecosystems over these regions. And then you can also see here, if we see over here, the circulation that is doing this, so is again the upper troposphere anticyclone that is associated with the divergence in the upper levels, and this is the monsoon anticyclone in the upper troposphere that is rotating clockwise, like the other monsoons in the northern hemisphere. And when we go to South America, then we see that the wind is blowing, always coming from the Atlantic Ocean. But here, when you compare winter, this will be Southern Hemisphere winter with Southern Hemisphere summer, you can see that although there is not a reversal in terms that the wind is coming from the land to the ocean, you are observing a change in the wind direction, because here you have very zonal winds in the lower levels, but then when you are in summer, you have winds that are directing from the east but to the south. So you see here this red arrow that is showing us like how the circulation is changing and is bringing then moisture that will be important to feed the South American monsoon. You can see a very extensive area that is affected by this system. In comparison, for instance, with the North American monsoon, or in comparison with other monsoon regions, this is a very broad area affected by this. And in part, this is associated with topography. That is something that I haven't mentioned so far. Here in these inset maps, you can see some brownish colors. Those are representing topography. So clearly, you can see here, for instance, the Andes, that will be super important for the South American monsoon. Or you can see here the Sierra Madre, that is very important for the North American monsoon. Or, for instance, you can see all the, like the Tibetan Plateau and the Himalayan system, that will be very important for the Asian monsoons. And in general, you can see that there is topography like associated with these circulations, but you can see also that the height, for instance, of the Himalayan system, or the height in the Andes, particularly more to the south, is very high in comparison with the height that you can have, for instance, in the Sierra Madre, or in other areas, for instance, in Australia or in Africa. So again, each of these monsoons that we are trying to put like in a common place, that they have similar features, they can have very distinctive behaviors, and somehow the background, the topographical background, the land use also. Please consider here that we have something as big as the Amazon forest, but here over this region, for instance, in North America, you don't have that type of rainforest. You have more actually semi-arid regions. So the landscape and the vegetation type that is associated with these monsoons are pretty different when we compare, for instance, the American monsoons. And that is also happening. For instance, here you have more the Congo tropical rainforest, but there here you have another type of vegetation. And again, if you go to Asia and the Australian and maritime continent region, you can also have, this is for instance a tropical forest, but very fragmented, because they are islands. It's not a huge continental landmass, for instance, like the South American continent. This is a more fragmented area. So of course you have differences in atmospheric circulation, and also in ocean circulation that will be also important, more in some regions than in other regions. So again, here the idea with this figure is to show that yes, we have systems that they share some of the features that had been like canonically established as a monsoon. Again, the first literature on monsoons are from the 1600s, so it's quite a long time ago that this literature came out. Of course, the concept has been evolving. Science is always in evolution, and it's quite recent, the introduction of the concept of the American monsoons in comparison to other monsoon systems. And you can see still those struggles in terms of what the wider international community, again, global north dominated community, recognizing as a monsoon. Because, for instance, in the last IPCC report, the last report of the Intergovernmental Panel on Climate Change, the South African monsoon was not recognized as a monsoon circulation because of the debate and the discussion that is in literature. But it's important to bring the fact that there is a huge community in South Africa and in other regions that understands the circulation, and that also understands the importance of this circulation for the regional climate. And that's why I guess we need to also have like a wider perspective of science. It's not only something that comes from the from the common agreement among scientists, but also who are those scientists that are agreeing and who are the scientists that are not agreeing with this particular conclusion. And sometimes it's again the power imbalance that is in the world in many aspects is also a part of science, because science is developed by human beings. So it's also permeated by these behaviors and by these cultural and power unbalanced relationships. And that is something that I really wanted to bring, because it happens with the South American monsoon at some point, not now. I think now is much more accepted that, but you can see some resistance sometimes when you talk about the American monsoons, that they don't consider that they are necessarily as excellent monsoons, let's say, as for instance, the Asian monsoons. So that's why the critical mass of scientists that are from a particular region giving critical and very well-informed perspectives of science is super important. Otherwise, we will have then some dominating views of science that there are some particular, in this case, monsoons or particular aspects of climate that are more important than others, not because of the science, but more because of the region where they are, right? Where they occur. And that is something that we can also see regarding, for instance, the regional monsoons. So that's why I wanted to bring this to have this parallel between the different monsoons. And also the implications they have in terms also of the scientific, and sometimes not that very scientific, but the debate that is in the science arena. So that is like the introduction, like recopilating some of the ideas that Michelle gave last week in terms of the definitions of monsoons. And now my idea is to focus on the American monsoons for the rest of the class. I forgot to mention that if you have any question, here I don't see the chat because I only have one screen, so I don't see the chat, but you can open the microphone if you have any question. I think I'm sorry, it's because I need to change or I don't know if maybe Michelle can help me if there are questions or there is a upper hand, because I need to, Fabiola.
Yes, good morning. Thank you so much. Apologize because my camera is not working today, but my question is related to the monsoons. I was wondering if in the community, the scientific community, there is any information about the impact of warming ocean, let's say, since we are seeing that the SST is quite warm nowadays, and if this could bring some impact in the monsoons, since most of are related to difference in the temperature.
Yeah, of course. That is something that is widely studied around the world for the different monsoons, particularly for South America. As I mentioned, one of the drivers in the monsoon circulation is associated with this thermal contrast between the continental mass and the ocean. So, of course, if the temperatures are changing in both of them or in one of them, and it's changing more in one than in the other one, it will create changes in the thermal contrast, but also the circulation is changing. So yes, this is part of the research that we currently have. The class today will be more focused on the climatological behavior. So I will just at the end refer a little bit on climate change, but I won't give like a very deep discussion on how the American monsoons are changing because of climate change. But yes, this is a research field that is widely studied in the current science.
Okay, thank you so much.
Yes, Michelle.
We will have a special class about the Nino with Michelle Leroux from NOAA, and she will discuss these points that you are interested.
Okay, thank you so much, Michelle.
Perfect, thank you. So please, Michelle, if you see that there is one hand up or anyone is asking a question, please let me know, because I have to switch screens, okay? Okay, so I will go back to the slides. You are seeing again the slides, right?
Yes, you can go ahead.
Perfect. So here we are seeing an animation I really like. This is a very old animation using actually very old data, but I think it's very interesting to see it because it's actually showing us this annual cycle in the circulation in the Americas. So we are seeing the same elements that I mentioned before. In colors, we are seeing the outgoing long-wave radiation. Again, is like a proxy of the convection activity. So we can see like what is the rainiest area moving during the year. Again, you are seeing the arrows. The arrows are showing the low level circulation at 850 hectopascals. That is very low levels in the troposphere. And then we are seeing these streamlines that are the solid lines, the continuous lines that are showing us the upper troposphere circulation. And then here you can see also like in which moment of the year we are having the image. So if we go, this is going through Northern Hemisphere summer, then we go the transition toward the Southern Hemisphere summer, and then we are seeing like the annual march, in this case of the precipitation region. So this is also associated with the intertropical convergence zone, the one that is more in the tropical region. But then we are seeing, for instance, here, like in January, February, the development of the South American monsoon, the migration toward the north, and then to mid-year, we see here the development of the North American monsoon. Again, you can see the differences, much more convective activity, much more precipitation over the South American continent in summer. When we see here, the colors are much more blue, while when we go in the Northern Hemisphere summer and we go over this region that is the North American monsoon domain, we can see that they don't reach the same values in this case of OLR, but that is again associated with precipitation activity. It doesn't mean that the precipitation that occurs during summer in this region is not important. It's actually key for the functioning of the different ecosystems that we have there. And in terms of the low-level circulation, we can see very clear that the trade winds are always coming from the east, from the Atlantic, that in some months of the year, they are directed more to the north, and in other months, like in these ones, are directed to the south. So again, we can see here the wind direction change toward the south, bringing moisture to the Amazon and to the South American monsoon core region. And then when we are in Northern Hemisphere summer, here you can see the reversal in the meridional direction. And then you can see here the wind blowing from the Gulf of Mexico and from the Gulf of California toward the North American monsoon region. So we can see here the change in the low level circulation. And also you can see here, for instance, let's see here, all these upper troposphere divergence during the summer months. That is in this case is the Bolivian high, the high pressure system in the upper troposphere over Bolivia, mostly over the Bolivian altiplano. So that's why it's called the Bolivian high. And when we are in summer in Northern Hemisphere, so for instance, here you can see how these streamlines start changing, and look here that they start having more like a circular pattern that is associated with this divergence in the upper troposphere, and this is associated with the monsoon high in the North American monsoon system. So there we can see the transition, that there is a transition between both monsoons. And of course, this transition affects the regions that are not necessarily monsoon regions, but are connected with the monsoons, which is, for instance, where I live, that is here in the Northern Andes. We are not specifically within any of the monsoon domains, neither the North America or the South American domains, but you can see that the transition is actually happening over this region. For instance, in this time of the year, is more the precipitation, the peak of precipitation in the Orinoco River Basin, for instance. That is the third largest river basin in South America. The biggest one is the Amazon. Then we have the La Plata River Basin, and the third one is the Orinoco River Basin, more in between Colombia and Venezuela and the Guyanas. So there you see that even if the monsoons don't really occur over this region. This is a region, a transition region that is super important in terms of connecting the American monsoons, in terms of connecting, for instance, the Atlantic with the Amazon and the South American monsoon, or in terms of connecting the Southern Hemisphere with the Northern Hemisphere. So it's also like when you study the monsoons, it's not only focusing on the particular area where we have the monsoon domain, but that is connected with other regions, in this case also to the south in the La Plata River Basin, or over this region here in the South Atlantic that we will mention later. It's not only the specific geographical domain, but also the connections that they have in part because of the atmospheric circulation with other regions that are not necessarily within the monsoon domain. So having this in mind, we are going to talk about the American monsoons. We will start with the South American monsoon system. We will give some climatological features. Again, here is more what happens in a regular year. Here I'm not going to talk about how this monsoon has been changing during the recent years, or we are not talking about if an El Nino or La Nina occurs, then what is happening with the monsoon, anything on variability. We are talking more on climatology of the monsoon circulation in both American regions. So when we go to the South American monsoon, I'm taking this from a book that was edited by Charles Jones and Leila Carvalho. This is one of the figures of the chapter that was led by Leila Carvalho and Iracema Cavalcanti that is showing us something similar of what I already showed. Here we are seeing two screenshots, let's say, of the summer precipitation and low-level winds. In the left is the summer, December, January, February in the Southern Hemisphere summer, and June, July, August, which will be the Northern Hemisphere summer or the Southern Hemisphere winter. So in colors, you are seeing precipitation rate. If we have very bright colors, yellow colors, it means more precipitation. And if we see here the darkest colors in purple, it means less precipitation. So again, we are seeing the migration of the precipitation band between summer and winter. And we are seeing in the arrows the circulation, low-level circulation. So here is very clear that we are observing the trade winds that are incoming into the continent, but then you see the change in wind direction toward the south. And this will be very helpful to bring moisture in one part from the Atlantic, but also from the Northern Hemisphere toward the Southern Hemisphere. And also here we are not seeing, but this is the Andes Cordillera. So of course the Andes works like a channel for this low-level circulation, and actually it will enhance precipitation because of the orographic rising motion in some of these regions in the Peruvian Andes that are actually the hotspots of precipitation in the Amazon, one of the hotspots of precipitation in this Amazon region. So here you can see very clearly the circulation, typical circulation during the summer months in the Southern Hemisphere or in South America, let's say. And here we are seeing what happens mostly 6 months after, during the winter months. Again, we can see here the winds that are coming more to the north. So for instance, this is a way how we can export moisture from the Amazon toward the Orinoco Basin. Here you are seeing very well developed the Orinoco River Basin. Again, it's the third largest river basin in South America. So this is the rainy season. More mid-year, at this moment of the year, is more the rainy season in the Orinoco, while we are having the dry season more in the Amazon and other regions affected by the South American monsoon. So here we can see very clearly the change in the low-level circulation and the associated precipitation changes between summer and winter in South America. So here we see part of what we had in the animation before. And in this one, we are seeing again precipitation, so the colors are exactly the same that we had in the previous slide, but now we are seeing the upper troposphere winds. We are seeing 200 hectopascal winds. Again, the rationale that we have here is that if we have low-level motion, then we have a compensating upper level motion because of the mass conservation, energy conservation in the system. So if we have convergence in the low levels and rising motion, at some point in the troposphere, you will need to have a divergence and you will have a compensating motion in the upper troposphere. So here we can see that very clearly. When we have the convection over the monsoon system in summer, again, convergence, rising motion, and then you will need a divergence in the upper troposphere. And here we can see much clearly, look, the way the winds are behaving. So in this case, we are having the upper troposphere. If you see here, this is counterclockwise. It means divergence in the southern hemisphere. So we are having the divergent motion in the upper troposphere that is actually located over the Bolivian altiplano. If you see here, the Bolivian altiplano, and this is why this high pressure system is called the Bolivian high, because it's located over the Bolivian altiplano, and that is the upper troposphere most striking feature of the South American monsoon. So something that is very interesting of the monsoons in general is that it's not only a matter of what is happening in the low levels, but also what happens in the upper levels. And that's why I find this like a puzzle that is pretty interesting, because it's not only a matter of if we are having changes of wind in the lower or the close to the surface, near to the surface, but also what is happening in the upper troposphere. And that is a way like we can have a communication, let's say, a connection between the upper levels and the lower levels. So if something is happening in the upper troposphere, it can affect the low level and it can affect the monsoon circulation. It's not only a matter of what is happening in the surface is the only determinant factor. No, you can also have changes in the upper level that can affect the whole circulation. So that's why the Bolivian high is a very important feature in the South American monsoon. And that's why there are a lot of people that actually their research area is particularly focused on the Bolivian high and the different behaviors and changes of this upper troposphere anticyclone. Again, if we go to the winter months in the southern hemisphere and we go to precipitation, again, we see that the migration, the northward migration of the precipitation band is very clear. So we see here, for instance, the rainy season more in the northern parts of South America, particularly the Orinoco River Basin. But you can see here, for instance, the effect of topography. When you enter to Colombia here in this part, close to Ecuador, the Andes is split in 3 branches. So in Colombia, we don't have only one cordillera, we have 3 cordilleras. And that's why you have very different wind circulation depending on which valley you are, if you are in Cauca Valley or Magdalena Valley, and it will depend also on the land surface, etc. So you have annual cycles of precipitation that can be bimodal. It means 2 rainy seasons, 2 wet seasons, 2 dry seasons. While, for instance, in the Amazon, you have only 1 rainy season, only 1 dry season. And in the Orinoco, you also have 1 only rainy season and only 1 dry season. So you have annual cycles of precipitation that are more complex. Because in particular because of the topography in northern South America, but more to the west, that is particularly Colombia, because of the changes in the topography. So you see this here, very well known feature of the southern hemisphere winter precipitation pattern in South America. And then you also see that here you don't see anymore the anticyclonic circulation in the upper troposphere. Again, compared with this, that we have here, this counterclockwise circulation, very well developed here over the Bolivian Altiplano. But then here you are seeing winds that are coming from the west to the east. Again, remember, this is in the upper troposphere. This is not in low levels. And this is like the anticyclonic circulation totally disappeared from this figure to this figure. And that is associated in part with not having now the the rising motion that we are having during the summer months. So you see here the contrast between winter and summer in the left and winter in the right in South America in terms of the monsoon circulation. And here we can see like more clearly the seasonal cycle of precipitation. So this is showing red colors means more precipitation, white colors mean less precipitation. This is precipitation rate. And this is showing, this is starting in July. So it's not the typical annual cycle starting in January, finishing in December. This we are seeing more starting in mid-year and finishing in mid-year. So again, it's July, so we are more in the Northern Hemisphere summer. Here you can see like the precipitation over the Orinoco River Basin and Northern South America. And then you see gradually, this is August, this is September, October, we are seeing like the mid of the month in each of the panels. So then you see like a progressive southward migration of the precipitation band over South America. So here you start seeing higher values of precipitation around December in the central Amazon. Then you see, for instance, that actually February is where we have the largest precipitation rates over this region. Although we also have important precipitation amounts in the north and in the south, in the core region. Then you see that by April, this precipitation starts being more weak, and then you start seeing a progressive northward migration of the precipitation area going to the north, again establishing the wet season in this region over here in the Orinoco. So here we can see that there is a gradual transition in precipitation. In part is associated, of course, with the warming of the landmass. When we are in Northern Hemisphere summer, we have a warmer continental mass over the Northern Hemisphere, so lower pressures over there, and then you have a migration to the north of the precipitation band, whereas in Southern Hemisphere summer, you have a Southern Hemisphere mass that is warmer, in this case South America, this part of South America, and then you have again lower pressures, and then this convection zone that is more located in the south. So you see this migration that we could see in the animation that I showed several slides ago. So that's why the start of the rainy season in South America, particularly in the South American monsoon region, is not the same. Again, if I go back, you can see that the rainy season, we start having precipitation values earlier in the year to the north, because at the beginning here you start having here in July in the northern, we see the rainy season in northern South America. Here we are in a very clear dry season, and then you start seeing the migration to the south. So precipitation starts occurring first more to the north, and then progressively start happening more to the south. So that's why the onset is when the rainy season starts. This is the month of the year where it happens. In colors, you can see mostly that in black is precipitation is starting in August. In red is more late August. So, for instance, this one in orange is more like late November, by the end of the year. So you can see very like earlier onsets over the north, and whereas you are going to the south, particularly to the southeast, you start having later times of onset, and that is associated with in this case, southward migration of the convective region, and the demise the demise means when the rainy season finishes, then you start seeing that they start occurring earlier in the year over here, and then later in the year over the north. And again, it's associated with the same logic. The retreat of the convective zone starts happening from the south and migrating slowly, gradually to the north until we have again the rainy season over the north. So this is something that is again based on climatological data. 1 year you can have that the monsoon is starting earlier or later in the year in comparison to the year before or the years before. And this is part of the interannual variability of the monsoon. What I'm telling you at this point is something that is climatological, but it doesn't mean that every single year the monsoon behaves in the same way, that, for instance, the precipitation pattern is exactly the same every year. This is more from a climatological view, but year by year, you will have to check how is the monsoon progressing, and that is why the forecast is super important, and that is part of what this course is talking about. It's not only about the general features, this is just an introduction. It's also like how can we know if the monsoon is starting earlier in the year or later in the year, if the monsoon is going to be a strong monsoon or will be a weak monsoon, etc. So not all the monsoons are the same. They are actually, every year the monsoon has a different imprint. So that's why the forecast is super important in terms of monsoon, not only precipitation, but also the circulation, and also the Bolivian high, for instance, is an important feature, etc. So that's why you have research that is not only focused on the general behavior of the monsoon, but also the variability in terms of interannual variability, intraseasonal variability, decadal variability in many time scales, but also climate change. Because as one of the students asked, there are changes that are happening at the global scale in the global climate that are translating into particular changes in the South American monsoon circulation. So here we can see like a very typical climatological map of summer, Southern Hemisphere summer precipitation in South America. This is precipitation rate. So when we see in red is higher precipitation amounts, and where we see in purple is lower precipitation amounts. This is typically for the Southern Hemisphere summer for December, January, February, and it's a climatology of these 20 years between 79 and 99. So this is not an updated climatology, but this still gives you like a general pattern of precipitation in summer, Southern Hemisphere summer in South America. So we see three striking regions, one over here with large precipitation, another one over here. And we can see a third one that doesn't have as much as precipitation as these ones that are more tropical, but this one is an important feature for the South American monsoon. So here we have the monsoon core in South America. This is where you have the maximum precipitation in the monsoon region, and in part, if you can see, it's very close to where the here in white is more associated with topography. So you can see here part of the orographic lifting that is associated with the presence of the Andes Cordillera. There you see the intertropical convergence zone, the ITCZ, over the Atlantic, a very well-known feature also of equatorial and tropical precipitation. And then we see this one, that is another convergence zone, but now it's not a zonal convergence zone, it's not parallel to the equator, it's more tilt. So this is why they call this the tilted or obliquous convergence zone. And this one is called the South Atlantic convergence zone because it's over the South Atlantic. And this is a summer feature. So this is something that you see mostly in summer months. You don't see it much in winter months. And it's different from the intertropical convergence zone that you can see it through the entire year. This one is more a summer-like pattern of precipitation in South America. So you can see the three most striking features in Southern Hemisphere summer precipitation patterns in South America. Again, if we go to the upper troposphere, you are seeing here like the evolution of the upper troposphere circulation in South America. We are seeing here in the winter months of Southern Hemisphere. So this is more June, July, August. Then we are seeing spring. So it's more September, October, November. This is summer, the end of the year, December, January, February. And this will be autumn, that is more March, April, May. So these are the seasons in the Southern Hemisphere. And what we are seeing here, again, in these shades in gray, is precipitation rate. In the upper line, and in the lower line is the total amount of precipitation in the year, is the total annual precipitation. So again, we can see what we have already discussed. In winter, June, July, August, precipitation more focus on the north, and then in Southern Hemisphere summer, precipitation migrating to the south. So you can see here very clearly the South American monsoon core. This is the South Atlantic convergence zone that I mentioned that is pretty striking during summer. And then you see here, for instance, the intertropical convergence zone, in this case in the Atlantic. Here we have more in the Pacific. And you see that these features are mostly during the entire year that we see it, whereas there are other features that are more seasonal dependent. And again, here the focus is not precipitation, it's more the upper troposphere circulation. So here we are seeing streamlines, and in this case, this is the direction where we are having the upper troposphere circulation. So here we are seeing a very well-known feature in the subtropics. In this case, for South America, this is the subtropical jet stream, or the subtropical jet circulation that happens over this between 40 and 50 degrees south. You are seeing the west to east circulation that is actually happening at very high velocities, more than 30 meters per second in the upper troposphere. So this is a very well-known feature over here. And then you also see here, if I go in this direction, here the wind is doing this. In this case, is doing this. So you can see here like a counterclockwise circulation that again is associated with high pressure in the southern hemisphere. And this is the anticyclonic circulation that during the winter months is located more over the ocean. But then we see that when the year progresses and we go to the spring season more in September, October, November, we can see a migration of this anticyclone that now is more focused over South America. And then here you see like a very well establishment of this upper troposphere high pressure system that is actually the Bolivian high, that is BH, Bolivian high. So here you see the development, the mature phase, the complete development of the South American monsoon with this very well-known feature, anticyclonic circulation here, counterclockwise. And then if I try to follow the streamlines, then you see that the winds do this. And here they try to have a clockwise circulation. Again, this is everything in the upper troposphere. So this means clockwise circulation in the upper troposphere. In Southern Hemisphere, it means a low pressure system. So here we are seeing a low pressure system that is actually over the northeastern Brazil. That's why the NA, northeastern low, because it's associated with low pressure in the upper troposphere over this northeast or northeastern Brazil region. And something that is associated with this, if we have low pressure, because of the gradient force, then you will have convergence. And this convergence is happening in the upper troposphere. So the mass is accumulating here. The mass will need to have subsidence in the atmosphere. So this is associated with subsident motion. And when we have subsident motion, this is actually associated with adiabatic warming. And in that case, it's associated with drier conditions. So that is one reason why this northeastern region in Brazil, you live, many of you are in Brazil, so you know better than myself, like how is the precipitation over the country. But here is a very arid or semi-arid region that is particularly associated with this descending motion in the atmosphere, and that is connected with the Bolivian high. because you have here this, and here you have a compensating motion that is actually promoting subsidence motion over this region, more in the east of the continent and the Atlantic Ocean. And then when the monsoon starts retreating, starts demising, finishing, then you see again like an establishment of high pressures over here, but now not the Bolivian high, but weaker high pressure system, until you go back to the circulation that we had before, that is this high level pressure more into the oceanic area of the Atlantic, whereas the continental landmass doesn't have that striking feature. So you can see that even if we have a low level migration in terms of the circulation, you also have changes in the upper troposphere circulation. And that makes this super interesting of studying, because if something somehow changes in the upper troposphere, it will be translated in changes of the rising or subsiding subsidence motion, but also in the low level circulation. So the whole troposphere is connected in the monsoon circulation. And again, this is just like a screenshot of the summer, Southern Hemisphere summer of the upper troposphere circulation in South America. So here you are seeing streamlines. Again, here we can see the winds blowing from the west to the east. And in colors, the shades mean speed, wind speed. So for instance, you can see here wind speeds that can be higher than 35 meters per second, for instance. So it's actually telling us a lot that there is a lot of, the wind has a lot of speed, very fast winds. And then again, we can see here the features that I just mentioned. This is the Bolivian high, very well developed, with this anticyclonic counterclockwise circulation here. So it means divergence in the upper troposphere. Then we have, if we go with this circulation that tends to have a cyclonic circulation in the southern hemisphere, this is clockwise. And this again is associated with convergence in the upper troposphere and subsidence motion. This is called the Nordeste or the Northeast low. And then here, this very well-developed zonal circulation from the west to the east at very high velocities is the subtropical jet in the southern hemisphere. So we can see the three most striking features of summer upper tropospheric circulation in South America. Here we can see better the Bolivian high. Here I want to focus on the Bolivian high. So this is an image that is showing us, again, the winds in the upper troposphere at 200 hectopascals. And there you can see very clearly the circulation that is counterclockwise. And when we are in the southern hemisphere, this is associated with anticyclonic circulation and divergence. Again, in the upper troposphere, so it's the divergence in the upper troposphere. And there you are seeing the cloudiness. This is a satellite image of cloudiness that is showing us, for instance, here, the South Atlantic convergence zone. Here we are seeing a part of the Atlantic ITCC, and there you are seeing the spread cloudiness that is associated in part with the South American monsoon, but also with convection development in other regions that are outside the South American monsoon. And this is associated with a low-level circulation, which is what we are seeing here. So here we are seeing South America, here are the Andes. Again, we have to remember that we have the Andes, which are very high mountains that can also channel and change the development of the wind. Again, here you see the ITCC, which is this one, the Intertropical Convergence Zone. Then you see the anticyclones that I mentioned before. Here you are seeing the subtropical highs over this region here, the South Atlantic subtropical high, and this is the South Pacific subtropical high. So this will be somehow associated with moisture transport, in this case, toward this region in Chile, for instance. It's very important bringing moisture to this region. And here we are seeing more the transport to the south, in this case, over this region in the eastern continent. Here we are seeing also the South Atlantic convergence zone, that again is this one that we are seeing here, which is this convergence zone that is not zonal, but is more tilted. This is something that is called the Chaco Low, that is a low-level pressure system close to the surface, very low levels, and this is a very important mechanisms for moisture transport from the Atlantic toward the south and feeding the South American monsoon. That is the low-level jet, the South American low-level jet that is developed as a mechanism to bring moisture toward the south and to keep activity in the monsoon system. So we can see that this upper troposphere circulation that we are seeing here is associated with low-level processes as we are representing in this image. And here we are seeing what is happening in the upper troposphere, again associated with the same Bolivian high circulation. So again, this is the Bolivian high. We can see here like a counterclockwise circulation in the upper troposphere, and this is part of this large-scale circulation. As we saw in one of the images here, actually we are seeing this, and then we are seeing this type of movement here that is associated with this, and this is the development of the northeast low that is associated with this convergence in the upper troposphere and subsidence motion over this northeast area in Brazil, but also over the Western Atlantic. So here we are again seeing the same type of climatological circulation associated with the Bolivian high and, for instance, to the South American monsoon. So here we need to also understand that what happens in the Amazon is not only depending on the Amazon itself, but also depends on what happens in the Atlantic. For instance, if we go to this image, a lot of the moisture that comes into the Amazon comes from the Atlantic, both the North and the South Atlantic. So the Atlantic Ocean is a very important source of moisture for the Amazon. But also other basins in South America. Not only the Amazon, we know that there is a lot of precipitation recycling and moisture recycling in the Amazon. Some studies find that it could be between 25 or even 50% of the moisture that is precipitated in the Amazon is recycled by mostly vegetation, so by vegetation processes, evapotranspiration, etc. So of course, the Amazon depends on its own, on itself, to feed precipitation, but also there are moisture sources that are very important. One of them is the Atlantic, as I mentioned, both the North and the South Atlantic, but also other basins. In this case, for instance, I want to bring the attention to the Orinoco Basin, which is in the north, and it's because of the movement that the wind has. Before entering into the Amazon, the wind comes from the Atlantic. It crosses part of the northern bases, crosses the Amazon itself, but also there you have the Andes. So there is this system that is called the Atlantic Andes Amazon connectivity, because we have the connection between these three big systems. It's not only the Amazon itself, it's the connection with these three systems. And in this case, I really want to highlight the importance of the Andes for the Amazon, for the South American monsoon. Sometimes you see some views of the Amazon itself, like it's depending only on the Amazon, but the Amazon River starts in the Andes. That's where we have the tributaries of the Amazon to contribute to this big river. They are starting in the Andes. So the Andes are super important in terms of liquid water, of course, but also nutrients and sediments. The Andes is the main source of nutrients and sediments for the lower Amazon water. So that's why we need to consider also the Andes as a very strategic, a very important part of the Amazon system, and not only the Amazon, the South American monsoon system. Without the Andes, we will have a different system, right? Where we won't have, for instance, the hotspots of precipitation that we have over here in these regions, more in Bolivia and Peru, because we wouldn't have the uplifting, the orographic lifting that we have because of the mountains. And also we have again, a lot of moisture export that comes from the north and that goes to the south. So here we have a lot of connections, and that's why I wanted to bring this. Like we have, of course, incoming of moisture from the Atlantic. We have a lot of evaporation in the Atlantic Ocean that condensates actually in the atmosphere. And of course, that is something that is affected by warming of the Atlantic waters. Then we have mechanisms like, for instance, the aerial rivers that can transport at high velocities, very high amounts of moisture in the atmosphere. We also have evapotranspiration processes that help to recharge these atmospheric moisture mechanisms. We also have, of course, precipitation along the Cordillera, along the Andes. And then we have also processes that feed sediment and nutrient transport toward the lower lands in the Amazon. Again, the water supply, liquid water supply that the Andes represent for the Amazon is super important. And that because of all of these interactions is that we can have also these huge amounts of precipitations that are important to sustain, for instance, something like the Amazon rainforest. Of course, the Amazon rainforest itself is a source of moisture for the Andes. Yeah, in terms of not liquid water, but more, or yes, liquid water, but more in terms of aerial transport, not surface transport, and also water vapor, of course, that is in the traveling through the atmosphere. So here, what I wanted to highlight is that when we see the South American monsoon, we shouldn't see only the circulation that is mostly focused over a very large portion of the Amazon, but that is also connected with other regions like the Andes, like the Atlantic, but also with other basins that are not necessarily monsoon regions, but that are super important in the connections and the behavior of the South American monsoon. So we should think bigger. We should have a bigger picture of what is happening in terms of the regional circulation. And here, this is a transect. Actually, what happens, this is more like if I go from the northeast and I go to the southwest and I do a cross section, this is what we will see. So here is the Atlantic in the northeast, and there we see here the Pacific in the southwest. So here we are seeing the lowlands in the northern and southern Amazon, and here we are seeing the topography. If we go this, so here we will see the topography that is mostly the altiplano in Bolivia. So we see that a lot of moisture is transported from the Atlantic, mostly like in the low levels. Here we are seeing something that is coming like from the screen towards you. Here in this direction, entering like from, or going out from the screen, we are seeing the low level jet. That will be more this circulation that is going to the south here. So you are seeing this also as a mechanism for atmospheric moisture transport. We see here the Bolivian high in the upper troposphere that we already discussed. We have also the orographic lifting over the altiplano slopes that will be super important to produce precipitation over these regions here in the Piedmont of the Andes. And also we see here other circulation that is more in the other side of the Andes, more in the altiplano, that can also contribute here with precipitation more in the highlands of the altiplano. So we can see here that we have atmospheric moisture transport and that we have circulation that is, although I see it like this and I really don't see where this comes from, when I see this 3D picture, then I start seeing like there is a connection that it goes beyond the Amazon and goes beyond the South American monsoon itself and includes other regions in South America and in the ocean. So this is like what I wanted to bring regarding the South American monsoon. You will have other classes that are associated more with teleconnections, for instance, in the South American monsoon, more with predictability of the South American monsoon, more on recent changes in the South American monsoon, the interannual variability, for instance, with El Niño, La Niña, or with other modes of variability. So here I just wanted to bring a big picture, let's say, of the climatological behavior of the South American monsoon. Now we can go to the other American monsoon, to the North American monsoon. We will see that this is a monsoon that is smaller in terms of the geographical extent that it affects, and also in terms of the intensity. Precipitation rates in the North American monsoon are much weaker than in the South American monsoon. Again, it doesn't mean that this monsoon system is not relevant for the ecosystems in which they occur. They are actually, these monsoon rains are actually very important to sustain the ecosystems over this region in North America. So here we are seeing a map that is showing us how much of the annual precipitation occurs during July, August, September. That is, like, let's say, the monsoon season in North America. So we are seeing that if this is 90, it means that 90% of the annual precipitation, of the total precipitation that falls in 1 year, actually falls in these 3 months. So this is really showing that the monsoon precipitation is super important for that particular region. And then you can start seeing that there are regions where the July, August, September precipitation doesn't represent much of the total annual precipitation, but then you see regions where it can be more than 50%, 60, even 70% of the total annual precipitation. It means that it doesn't matter if it is a lot or a small amount of precipitation, the one that falls in these summer months are crucial to sustain natural systems, but also human systems over this region. So you can see here, this is like a rectangle trying to show like the monsoon core in North America. Again, you can see that there is precipitation. Actually, in some parts, precipitation is larger over the equatorial area, but this is the region that is like generally assumed as the monsoon region in North America. So you can see that it includes part of Mexico, but also parts of the United States, the southwestern United States. And here you can see like how much is the precipitation rate over this region. So this is a domain average of precipitation rate. This is the annual cycle. So this is January, February until December, and you can see that here the peak of precipitation is mostly in June, July, August, September. July, August, September is like the one with higher precipitation over this region. And you can see that the values could be as high as 4 millimeters per day, which is actually, if I go to the South American monsoon and try to see one figure, for instance, here, you can see that over here in the monsoon core, it could be 9 millimeters per day. So it is about half of the precipitation rate in the South American monsoon. Is weaker in terms of the total amount of precipitation, but this is super important because, again, this represents about 70 or more % of the total annual precipitation. So here we have to see the monsoons in relative terms and not necessarily in absolute terms, because then we start seeing differences between the regions. This is more like how the precipitation behaves in the peak of the monsoon. So this is not the whole annual cycle. This is more in the peak of the monsoon. So we are seeing June, July, August, September. Here we are seeing the total amount of precipitation that falls in that month. Again, we see that the largest values are over the equatorial region, but then we can see here an important migration toward the north. This is the rectangle for the monsoon region. So you see June with some precipitation more to the southeast here in Mexico, but then you see this progression toward the north in July, August, mostly where we have the highest amounts of precipitation, and then you see the starting of the retreat toward the south more in September and October. So you can see also this seasonal migration, meridional migration, as we saw in the case of the South American monsoon, although we see here like this area, for instance, is much reduced in terms of the extent. In South America, we could see like a huge part of the South American continent, about half of the South American continent covered by this precipitation amount. Here you are seeing a very restricted area, and that is also associated with topography. but also check this region. This is a very narrow landmass in comparison to South America, that is a very wide landmass. So of course, this will also create differences in the behavior of the monsoons. So here we are seeing more a little bit of the features that act in the North American monsoon sorry, in terms also of moisture transport. So again, we see a very narrow landmass. We also see this one that is very narrow. Actually, you need to have high resolution data to see this, but this is the Gulf of California, and there you have the Gulf of Mexico. And actually, most of the moisture that comes into the North American monsoon in the low levels come from the Gulf of California. So comes from a very narrow area. So of course, this monsoon was very difficult to identify this monsoon 50 years ago, because if you go to the reanalysis, they were very coarse in resolution. We didn't have much of satellites, for instance. So it was mostly during the last 3 decades that data started having enough horizontal resolution to start resolving and seeing actually the behavior of moisture transport. That's why the North American monsoon was not considered a monsoon, neither as the case in the South American monsoon, because the different data sets didn't show any reversal at all of the circulation. But then when you see, for instance, QuickScat, that is more a wind scatometer that can help you to see the wind, or when you have wind profilers based in radar technology, that is something that is more recent, you really could see the reversal of the wind coming out or coming in from the Gulf of California. So again, also the struggles to understand a particular physical system when you didn't have enough tools to observe that particular system. The South American monsoon is much larger. Of course, there are very detailed features that need a lot of high resolution data, and that will improve, of course, because you have a lot of land use changes, etc., deforestation that is happening and that is affecting. The topography, of course, is very irregular over the region, but here we have also this challenge of being happening in a very narrow area with a lot of changes in geography. Because here, for instance, you can see also the Sierra Madre, that is part of this topography that affects this region. So you see a lot of contrast and changes in very small distances, in very short distances. And that is a challenge, really. First, to observe and understand the monsoon, and second, to model the monsoon. The simulations over this region are very challenging. Over the South American monsoon also, because topography, also because of land use, etc., vegetation that is super important there. And here we have other challenges that are very associated with this is a small piece of land that many models really see as one pixel, right? They don't really see what is happening here. So here I wanted to show that a lot of the low-level moisture comes from the Gulf of Mexico. This is what the blue arrow here is showing. In general, we have a low-level pressure system, a low pressure system in the lower levels here. That's why they are showing here this as a counterclockwise circulation. Here, the circulation changes, so now the low pressure is in counterclockwise, the high pressure is clockwise because of the Coriolis effect. So here we are seeing the thermal low. It's because of the warming of this continent in comparison with the ocean. So we have a thermal low induced here over this region, and that actually promotes in part the transport of moisture from the Gulf of California toward the monsoon region. Here we see like the monsoon core, where we have the highest precipitation rate over the monsoon, where we have a lot of thunderstorm activities. The fact that the precipitation rate occurring over the region is about half of the precipitation rate in much parts of the South American monsoon doesn't mean that we don't have important convective and thunderstorm activity. Actually, this is a region where we have a lot of thunderstorms during the monsoon season. Also, we see the moisture transport that not that much at the low levels, but more at the mid levels that comes from the Gulf of Mexico. So this is a secondary source of moisture toward the North American monsoon. So again, we are seeing that the moisture doesn't come from one single source, but comes in this case from two oceanic and very narrow actually areas of the ocean, the Gulf of Mexico and the Gulf of California. In the north, we have westerly wind that comes in this direction, and then we also have a compensating subsidence motion over here in the Great Plains, what they call the Four Corners, because it's the connection between these states, Utah, Colorado, Arizona, and New Mexico. This region where the four states connect is a region where you develop a high pressure system that is a compensating system of subsidence over this region. And that helps again, if you have here, then the transport of moisture toward the monsoon, toward the North American monsoon region. Here we can see more of what I was talking about. So here we see the landmass, like more in white. Again, this is the California Gulf, and here is the Gulf of Mexico. In color, they are trying to show like moisture that is transported. And here we also have to put the upper troposphere, right? And in the upper troposphere, as in the south, we have the subtropical jet. In the north, we also have the subtropical jet. This is the northern hemisphere subtropical jet. So what happens during the monsoon season is that this subtropical jet that can be very curvy moves to the north. So it migrates a little bit to the north. And in that manner, it allows that more moisture can be transported to the south toward the monsoon region. So we have a jet stream that has a dry westerly flow, moves more to the north and allows like a southerly flow coming from the southeast and the southwest toward the monsoon region. Again, this is the thermal low that I mentioned before between here, the Baja California and the Gulf of California, and it helps bring in moisture from the Gulf of California. Then you have the transport of from the Gulf of Mexico. And here we have the high level pressure that I mentioned just before, clockwise, right? And this allows, when you see this, the movement of atmospheric moisture toward the region. And then you have also the role of the topography. So here you have like a very well channeled moisture transport between the high that is here and the low. So the air that is coming from here and the air that is coming from here is very well channeled to the north, and this really helps in the occurrence of thunderstorms. This is what these symbols are meaning, that there's a lot of thunderstorm activity over this region in North America. So again, if I do a cross section from the east to the west, so here we see the east, here we see the west. So it's something that I'm doing like in this direction. I'm going like this, right? So you see the Gulf of Mexico, you see the landmass, and then you will see for here the Gulf of California, and then we'll see a very small landmass, and that's what we are seeing here, right? So again, we are seeing moisture transport more in the mid levels from the Gulf of California. We are also seeing a low level moisture transport from the Gulf of Mexico. And in this case, I will have to see two low level jets that are entering to the screen. Over here, the Great Plains low level jet, and over here, the California low level jet. So they are going parallel to the topography that in this case is the entering to the screen that is the Sierra Madre Oriental. So again, Occidental. So again, you will see lifting, orographic lifting, and then it will create conditions for deep convection. Again, the convection over here in terms of the annual total is not as strong as in the South American monsoon, but again, this is a region with a lot of thunderstorm activity, and the precipitation that falls into the summer months is about 70% of the total annual precipitation. So it's important to have that into mind. Again, another figure showing the same, but here, I guess the additional information is that it's showing us the topography that we haven't seen so far. So again, we are seeing this moisture transport from the Gulf of California, from the Gulf of Mexico part, and also that comes from this high level pressure that is here. So it helps channeling this moisture transport toward the monsoon region. You have a lot of monsoon thunderstorm activities. And in this case, what I wanted to show is that the presence of the Sierra Madre Occidental is super important because then, in one hand, you can have orographic lifting because of all these low-level and mid-level moisture transport processes and the orographic barrier. You have a lot of thunderstorm activity. And also, this is a region where a lot of flash floods occur. So again, it's not only the atmosphere, we have to connect to the surface. And in the surface, you have vegetation, you have topography, but you also have people, and you also have human systems. So again, this is a region that is very affected by these flash floods, particularly in these months of the year. So you can see in this image that is more an animation. Actually, this is an image that is showing us, a satellite image that is showing us this atmospheric moisture process transport that occurs. Again, here you are seeing the Gulf of Mexico. Here you are seeing Baja California in Mexico. This is the Gulf of California over here, right? So this is Mexico, and this now is the US over this region here. No, the US starts over here. This is Mexico. So you can see really a large scale, quite a regional scale moisture transport that comes into this region. And then here, when you start seeing these green and red areas, is because it's associated with thunderstorm activity. So you are really observing that this is something that is happening with this circulation that I am also mentioning. And this is the image of the landscape that you have in the North American monsoon. When you think the South American monsoon, of course, the whole South American monsoon area is not the Amazon. I mean, you have semi-arid areas, you have more the altiplano that can be more like another type of vegetation. It's not everything is, even the whole Amazon is not the deep forest, right? You have transition forests between the Andes and the tropical forest. So you don't have like only one single type of vegetation, but in general, you can imagine a very vegetated area. But when you go, for instance, to the North American monsoon, you have to think that it's actually happening in a very semi-arid area, right? So this is a landscape, a typical landscape of the North American monsoon. This is actually a monsoon rainfall event in that area, or in the Sonora Desert in the Arizona region in southwestern United States. And again, it's explaining why, even if we have half of the rain rate falling in the monsoon season in North America in comparison to South America, is critical for the ecosystems that are here. These are ecosystems that are very dependent on water. When you go to the Amazon, they be more depending on radiation, for instance, on energy. So they are quite different ecosystems with different functioning. And again, the importance of this contribution of precipitation during the summer months is super important in these particular landscapes. So again, having in mind that if we talk about monsoons and we start having similar features, they are quite different. They have quite different personalities in one region or in another. So now, to finish, I just want to bring this idea that the monsoons in the Americas are connected. And we already saw an animation that is showing us the migration of precipitation and the circulation between the north and the south that is happening during the year. This is like images from the southern hemisphere summer and the northern hemisphere summer of the circulation. This is similar to what I already showed. So here, the lightest blue means more precipitation accumulated during the season. And then you are seeing the topography. Here is more clear what is the topography. So this is the Andes, and here we are seeing the Sierra Madre. And in the purple arrows, we are seeing the low-level circulation. So again, a circulation going to the south channelized by the Andes and associated with the huge precipitation here over South America. And then in the Northern Hemisphere summer months, you have a circulation that channels the atmospheric moisture transport from the Gulf of Mexico and also from the Gulf of California toward this region in North America. Although you can see that in the northern parts, the amounts of precipitation are much less than in the southern parts. So you see this transition between the American monsoons. And that's why if I do, in this case, what I'm going to do in this figure is a cross section. So I'm going to go into this direction here over South America in the South American monsoon time, and over North America in the North American monsoon time. I see something like this. This is for the North American monsoon in the left, for the South American monsoon in the right, and we are seeing the precipitation rate that falls, and this is the annual cycle. So this is January to December. So you can see like the precipitation occurs mostly in the mid of the year for the North American monsoon, and more in the late and beginning of the year in the South American monsoon, and that there is a migration that is associated with the location of the monsoon. So here, for instance, you can see like more in the south, more an equatorial migration when we go through the year. That is because it's going to the south, whereas here we are seeing again a northward migration of precipitation during the monsoon months in the North American region. So this is like something that we did a long time ago, like trying to study these connections between the American monsoons. And it's somehow the idea that when we start having a monsoon onset in North America, it means we start having circulation that is promoting moisture transport toward the north, a rising motion there, and that we have precipitation. Then you start having like this connection that when you have this onset in the North American monsoon, it could somehow also help to drive the retreat of the South American monsoon. Whereas where we have the opposite, the onset of the South American monsoon, then we have the reversal of the wind flow toward the south. And in this case, this could be also contributing to the retreat in the North American monsoon. So it's also seeing that of course, each one of these monsoons have their own sources of variability, their own personality, as I mentioned. There are connections between them that probably deserve more research, and that we need to understand better the connections between these two monsoon systems. Again, considering that this landmass that is actually very complex, because it's Central America, that is very narrow landmass, a lot of oceans, and we also have Northern South America, also are part of the, let's say, the translators between the North American and the South American monsoon. And something that we have understood is that there are actually changes in the timing of the American monsoons, that the North American monsoon is retreating earlier in the year. It means that it is finishing earlier in the year, whereas the South American monsoon is starting later in the year. And this is associated with a very well studied and established change in the Amazon, particularly southern Amazon precipitation, and it's that the dry season in the Amazon is lasting longer. So we have longer Amazon dry seasons, and it means that the onset of the rain season, that is mostly the monsoon, is starting later in the year. So what we are observing is that the transition between the North and the South American monsoon is lasting longer. So we are having longer transitions between the onset of one monsoon and the retreat of the onset of the other monsoon. We are having a longer transition season, and this could have also implications in terms of the regional climate, but also more at the local and regional level. Again, this is something that deserves more exploration. For instance, in the recent years, are we observing these changes in the North American monsoon, because in the South American monsoon, this is very well established. It's something that has a lot of confidence. Many studies, recent studies, also climate change scenarios and deforestation scenarios suggest that the Amazon dry season will last longer if we keep deforestation, if we keep with greenhouse gases emissions, but probably we need more focus also on the North American monsoon and the interaction with the South American monsoon. And we understand that these changes are associated also with changes in modes of variability, particularly having things like the ENSO, changes in the Walker and Hadley cells, but also in terms of the decadal variability in the oceans is something important to drive these changes. But also we need to put the fingerprint of human activity in terms of greenhouse gases emissions and how this could affect circulation, particularly connecting the transition between the American monsoons. So this was like what I wanted to bring today. Mostly, as I mentioned, I wanted to focus on particular aspects of the climatology of the American monsoons. You will see more details in the remaining classes.
Thanks, Paola. It was an amazing overview about the American monsoons. Thanks a lot. We have some doubts because I saw some hands. Ebenezer, I saw your hand. No? No doubts? Paola explained a lot of things. And let me see if the students... Okay. I think we can discuss one interesting...
Michelle, please
yeah?
check the chat.
Okay. Pedro has a doubt. Why Bolivian High is not located exactly where there is the maximum of convection?
I am not an expert on the upper troposphere circulation. Maybe Michelle could help me there, but it's associated with the compensating motion that you have in the upper troposphere. That we also have winds that are actually shifting somehow the circulation. So the uprising motion is not necessarily like this, totally perpendicular to the surface, but you are also having compensating divergence over there that actually tilts the location of the maximum in terms of the high upper troposphere circulation. You see the same in the Tibetan Plateau, for instance, in the South Asian monsoon, that you have the maximum of convection in one part of the South Asian continent, but actually is more to the north, the location of the Tibetan high. So it's associated with these compensating motions in the upper troposphere.
Yeah, I remember that Pedro Dias from USP has a very old paper showing how the waves in the atmosphere, the tropical waves, interfere in the high and displace its southeastern the position of the maximum of convection. It's associated with tropical circulation. Questions? Comments? Paola, thanks a lot for your presentation. If the students have any doubts or questions, they can send me by email and I collect all of them and I can discuss with you. I will ask you to send me a copy of your presentation because I will put available on Moodle platform. That is the place that the students find all the contents and the quiz because they need to answer the activities.
Perfect. Yeah, I can share the PDF. So you have also the links. I try to put the links of the animations or the information that I took, so it will be useful for you.
Yes, thanks a lot. And I will finish this wonderful section and we can see each other again in the next Tuesday. Luis Jesus is writing for us. Thank you for the presentation. I only have one question. What are your thoughts about the theory that established that all monsoons should be viewed as a system?
Well, yeah, like the global monsoon. That is this concept of the global monsoon. Yeah. For me, it's quite, I struggle with that because yes, I understand that in general you can have this connection between the north and the south. That is the migration of the convection toward the warmer land. I can have that, but the point is that I find very difficult to follow, and particularly what is the usefulness of that concept when the regional features are quite different, and they are associated with topography, with land surface, with actually regional circulation patterns that don't emerge at the high large view. So yes, I understand why they put it, but I think it's not very useful when you start having, okay, what is happening in South America or what is happening in North America. Then you start seeing very different things. And if you go to Asia, etc. So for me, when you talk about monsoons, for me, it's super important to talk about regional monsoons. I mean, what is happening in the regional level. But yes, I understand. And again, it's again of the view of who puts the view of the global monsoons, from which institutions, from which countries, what are the ideas behind. And that's why it's important to have the regional monsoons community like super empowered also to give what is super important to keep having the view of the particular monsoon.
I agree 100% with you because each region has its specificity. So we need to evaluate to discover the challenge of each region. It's not possible to have a generalization of the system.
Exactly. Otherwise, the South Asian monsoon will be always, and that's something that you are in these arenas, Michelle, sometimes what you feel the pressure that like everything, when we talk about monsoons, everything goes to the South Asian monsoon. I mean, the Indian monsoon, that is the monsoon. And then you talk about other monsoons and it's like, no, that is not really a monsoon. And it's again, because it's this idea that is very colonizing, the idea actually, that there is only one thing that is filling the full requirements. The point is who put those requirements, right? So that's why, again, it's not neutral. I mean, we are also people who can give our own perspectives, and that's why it's so important to have people like yourself. You are here with very clear theoretical background, understanding what is the process and why we need to understand the regional aspects of the monsoons. And in that case, it corresponds to us to understand them. Probably the British or, I don't know, other people won't be interested, but it's actually super important for us.
Yeah, we need to help the community to view the system and to view the specificities of each monsoon region. And for this reason, we have these cars specifically to focus on our continent. So thank you again. I think we can finish this section and see you next Tuesday.
Bye.
Bye. Thank you again.
Thank you.
Bye.
All right. Thank you.
Bye, girls.
Thank you very much. Have a good day.